Hi students, good morning. This is Venkat, teaching A-level AS and A-level physics. Today we are going to look at a very interesting concept, that is calculating uncertainties. So this is very important for paper 5. Every student who is doing A-level should understand how to calculate the percentage uncertainties and fractional uncertainties and absolute uncertainties. So that's what we are going to look at today. We have um, paper 5. Some of the questions, like you might have seen in the paper 5, question number 2, you have to complete the columns. Some columns will be given a value with its absolute uncertainty, and you have to square the value, and you have to include the absolute uncertainties of those squared values. So how we can do this? And some quantities will be given. For example, x will be given. You may have to find 1 over x, and you have to include the absolute uncertainties. In some cases, some values will be given. Then you will be asked to calculate the logarithmic value, and for calculating the logarithmic value, you have to put the absolute uncertainties for those values. So in those scenarios, how we can um, measure the uncertainties. That's what we're going to look at today. Okay, let us first start with the fractional uncertainty. So this is AS level stuff. Anyhow, just to recall that. So for example, if a quantity x is given, x is equal to 0.28 plus or minus 0.02. So we can easily calculate what is the fractional uncertainty in this quantity. It is fractional uncertainty in x is del x over x. It is 0.02 divided by 28. So which is equal to 0.07. And we can also calculate the percentage uncertainty applying the same equation, that is del x over x times 100. So del x, the fractional uncertainty already we have calculated, which is 0.07 times 100, which will give you the percentage uncertainty. Okay, that is equal to 7%. Now the problem comes here. Include the absolute uncertainties in x square value. So far it is very simple. So to calculate the fractional uncertainty and percentage uncertainty. So this is what you learned in most of the cases in AS level. Now, how to include the absolute uncertainty in x square? So the first step everybody should do, that find the squared value of x. So first, to find the squared value of x, that is equal to 0.28 square, that is equal to 0.0784. And then find the fractional uncertainty in x square. So the fractional uncertainty in x square is equal to 2 del x over x, because there is an exponent, that is 2. So the fractional uncertainty in x square value is the exponent times its fractional uncertainty. So exponent is 2 times the fractional uncertainty, and you can see from the working that 2 times 0.02, 0.2 over 0.28, which is equal to 0.143. Now the absolute uncertainty is, again, just you have to multiply the squared value times the fractional uncertainty. Now, if you multiply this, already we have calculated what is x square value, that is 0.0784 times 0.143, which is given by 0.01. So always remember that the absolute uncertainty, you need to put 1 or 2 significant figures. So most of the time, it is better to use 1 significant figure that is accepted by the that will be accepted by exam. Okay. Then coming to absolute uncertainty in 1 over x. So we have already got the value of x, that is x is equal to 0.28 plus or minus 0.02. So first, to find the value of 1 over x is equal to 1 over 0.28, which is given by 3.57. And then to find the absolute uncertainty, so again what I said for x square, so 1 over x times its fractional uncertainty. So 1 over x, that is equal to 3.57, and its fractional uncertainty is 0.02 over 0.28, will give you 0.3, which is the observed uncertainty in 1 over x. So when you write this as 1 over x, that is equal to 3.57 plus or minus 0. Again, you can see the number of significant figures. So you can give one significant figure, or most of the cases follow one significant figure. Sometimes you can give two significant figures as well. Okay? And then the observed uncertainty in 1 over x square. So again, if you look at the x value, that is 0.28. So 1 over 0.8 the whole square, that is equal to 30. So again, the same still applies, that the squared value, sorry, here 1 over x square value times its fractional uncertainty. So the fractional uncertainty x square is 2 del x over x, and then you calculate the fractional uncertainty, then multiply with its 1 over x square value, you get the absolute uncertainty. It is equal to 2, and it is written as 13 plus or minus. Okay. And then you also have uncertainties in logarithmic values. For example, x is equal to 5 plus or minus 0.1. So first to find the ln x, and then you have to include observed uncertainties of this value. So first to find ln pi, natural logarithm of pi, that is equal to 1.609, and then you also find the maximum likely value, that is ln 5.1. So you can see x is equal to 5.0 plus or minus 0.1. So the maximum likely value is 5.1. So to find first step, find the value of ln of 5, and then maximum likely value, so 5.1. Then find the ln 5.1, that is equal to 1.629. Now the observed uncertainty is the difference between ln 5 and ln 5.1. That is the maximum likely value, so which will be equal to 0.02. So the observed uncertainty in ln 5, that is equal to 0.02. So when write ln 5 value, that is equal to 1.609 plus or minus 0.02. So most of the cases, question number 2, this is what will be asked. I think this video will be helpful to you when doing paper question number 2, paper 5. Thank you for watching this video. I'll meet you with another interesting video in my next video. Thank you again.